our blood, and we left off where we've been talking about the red blood cell, and we've talked about how it gets formed, how we have this one huge hemopoietic cell letting us know, giving rise, or the stem cell, I should say, for the formed elements, meaning the red blood cells, the leukocytes, and the platelets. So we've been looking at the red blood cells, the erythrocytes, and we know that they have a certain lifespan. When they mature, they sort of spit out their organelles, and then they do their job for roughly 120 days. When they have finished their job, like I said, because if one red blood cell makes a circuit around the body every minute for that hour, for that day, for those 120 days, it gets very worn out. So by the time, for the most part, the spleen, okay, because the spleen can help with the breakdown of that red blood cell.
Bless you.
Thank you. Then it has to go through the disposal. And did we talk yet about how it breaks down and we get the stuff like the bilirubin and the bilirubin? Okay. And then we have our, basically our control for the biggest way that we have control of the production of the red blood cells is from the kidneys. Because if you remember, I kind of showed that in this leaving of the heart, so blood that goes by way of the arteries, one of the first organs that it hits is the kidneys. And the kidneys have a tremendous blood flow. So if they detect low oxygen levels, they secrete their erythropoietin. So by negative feedback, if the oxygen level rises, the kidney stops secreting it. And remember, that's our negative feedback. All right? So, when we talked about this, is that right? Okay, and when they break down, none of the parts are wasted. If you guys remember, we return amino acids back to the bloodstream. We return the heme. We store the iron, and we use it all over again. So that way the body's not trying to have to continuously replace. Do you happen to remember how many red blood cells we produced in a day? Like, was it 2 or the 400 billion? Yeah, I think it was the 2, and was it platelets that were the 400 billion? Okay, so 200 billion red blood cells per day. So, body needs to have those materials, and it will do that by recycling the parts of the red blood cell. Some of the things I think we mentioned for disorders of the red blood cell, the polycythemia, meaning too many platelets, anemia, and then I think we sort of mentioned sickle cell disorder. And when we look at the structure of that red blood cell, on that plasma membrane, which don't forget is that phospholipid bilayer, okay? We had those glycolipids, and the glycolipids were that, and I know that's not a true sugar, okay? I just think, anyway. So, it has a chain of sugars that are actually off of the plasma membrane components. One of the things that those chains are good for, other than a lot of other things, but they help identify blood type. How many of you in here know your blood type? I used to. I forgot it. Okay. And I keep saying, you know, I'm going to go back by the Virginia Blood Services and have it retyped, but I just haven't done it yet. So blood types, definitely one of the biggest things for knowing your blood type is in the case of a transfusion. Anybody in here ever had to have one of those? Okay. Blood transfusions. It becomes very important to not only know your blood type, but whether you know if you're like that negative or positive, like O negative, O positive, and so forth. So, our blood types, they're known as the A, B, O groups. Those are the major ones. More than 30 blood types exist. They're just very rare. These are the ones that are the more common. People might say, well, A positive, A negative, AB positive, or AB negative. That's because these are the groups that are the most common in the general population. Typing, it's based on antigens and antibodies. An antigen, this is a protein, usually a glycoprotein or a glycolipid. This right here that I've shown you is a glycolipid. And if you guys remember, embedded into this plasma membrane are proteins. Some of those proteins can have the sugar chain, and that would be a glycoprotein. So these are going to be on the surface of the cell. So that sugar chain is literally extending into all of the fluid around the red blood cell. Remember the plasma and all that sort of stuff? So the red blood cell has these little sugar molecules hanging off of it, and it's unique to you. So your red blood cells would be able to have that sugar chain, and when you get tested or when you get typed, okay, it will let you know the blood type based on what they find. Now, in our body as a whole, antigens, okay, their job, help the body detect our self cells from foreign cells. Okay? So if we're thinking about a blood vessel, in this case, and I'm thinking about my little red blood cell, all right, in my vessels, my fluid, my red blood cells are going to have some type of carbon chain. That is to help it recognize that if another red blood cell is there and it has the same carbon chain, yay, we're good. But what if a red blood cell came in that had a different carbon chain? And that one is considered foreign. Is everybody following me? So let's say that these right here, which are my cells, meaning my self cells, let's say that would give me type A blood. But then this one comes in and it's B. Well, because the job is to make sure that it recognizes self cells and foreign is now invading, it needs to respond. And therefore, detecting that foreign matter generates an immune response. Now, I'm talking about it in blood right now, but this is going to happen in all the cells of the body, right?
So like everybody's red blood cells, I guess, have they have those proteins on them, and they all have the same molecular formula. But then there's like a separate group that's attached to it, and that would be like the A. There's like it's like the R group or something.
The RH.
RH is attached to them.
Which is going to let it know
that's the foreign one.
If we are negative or positive. Now, okay, it's actually two separate entities. Okay, because you're going to have those chains, those glucose, those sugar chains. Their job at this point right now is to just determine what is that blood type. Is it A? Is it B? Is it O? Is it AB? There's another part for that negative and positive, and that once again comes to play on that plasma membrane, and it's going to be a protein, all right? If you have it, that means the RH is positive. If you don't, you're negative. And so it's actually two different entities to determine whether it's negative or positive. But it is that RH factor.
But the A and the B, does that mean that your protein, like the molecular structure of your proteins is different, or?
Yes. So like the carbon chain that would be hanging off of that membrane, for A, it's a certain structure.
Okay.
For B, it's a certain structure. For O, it's not there. It's not there.
It's positive. It's not the same.
No. The positive and the negative are due to something different on the plasma membrane. Okay? So that would determine if you're negative or positive. Just to determine if you're A, B, or O, it's basically saying what is the structure of that sugar chain. Okay? Because A will have a certain structure, B a certain one, O's not there. But the negative positive, that's your RH factor, which is another piece that could be on the membrane of the red blood cell. Okay? So, if this would be the case where my self cells are A, but B got introduced, it's going to start an immune response. In an immune response, the protective, the protection is going to secrete antibodies. That is going to come from immune cells, white blood cells. Okay? So, my cells, all right, that would secrete my immune properties, they would secrete an antibody, all right, and basically that antibody would attach to the foreign matter. So the antibody